Thank you. Sorry. Hi, everyone. So thank you for coming. Thank you for being that many people. So today we're going to do a workshop on presenting how a RAG system works. So maybe some of you already know what RAG is, but we'll still go through the different steps of how to make this work and implement it with a notebook. And maybe afterwards you can play around with the system. So this workshop will make use of Ollama, that you maybe know, that is used to run local LLMs using quantization. LlamaIndex, which can be used to put the different pieces together. Basically, you can connect some language systems to vector database, for example, and do some RAG. How many of you don't know what RAG means, by the way? Yes, so some, okay. So RAG means Retrieval-Augmented Generation. So this means that instead of having the model answering questions based on memory, it will retrieve some documents and answer the questions based on the documents. So that's why we're using here a model from Ollama and a vector database. So a database, we use Chroma here, which is used to storing and retrieving the documents, with LlamaIndex in the middle that is used to orchestrate every piece together. But we'll get more in depth with how the system works later on. So yeah, we'll help you through the installation steps for having everything work locally. And we'll also present how the different part of the technology works. But first, I'll leave it to Maria to present the company.
Hi, everyone. So actually, thanks, LauzHack, now for hosting us. I don't know who, you're there. You said that it was going to be TikTok. Well, I'm sorry. We're still going to speak about Visium a little bit, but it's going to be short. Don't worry. Maybe before starting, well, introduce ourselves. So Victor, he was before working in Lausanne. Now he's working in Zurich, and he's a junior machine learning engineer at Visium. And myself, I'm Maria. I'm the talent acquisition. I think I've already spoken now with some of you. And yeah, I'm basically in the people department now. So anything related to RAG or machine learning. Before telling you a little bit about Visium, let's do a simple, let's say, survey from here. How many do you know already what Visium is, what we do, etc.? Just raise your hand. Okay, good. So more or less half of the people. So to present a little bit more our company, so in numbers, we are around 50 employees. No, we're an international team, so we have our mainly team based between Lausanne and Zurich, but we also have our team in Valencia, in Spain, and in Bosnia, as you see here. And Visium is a data consultant company. I'll explain a little bit further now what we do, but basically just to give you more insights on the numbers, we've done more than 200 AI and data engagements. Now it's been 6 years since the company started, and we have more than 50 happy clients. And basically, in a little bit more numbers, so we were recognized as the second fastest growing company in Switzerland last year. And you see, that we have some partners now, CPFA, ETH, and then technological partners. And basically, I think the most important thing, and you'll be able to, apart from Victor and myself, speak with Leo and Lucas, who are here for the apero. It's our team. This is our team, more or less all of us during last year events for Visium anniversary. And basically, I will summarize, let's say, our team with this. So it's world-class talent because majority of our engineers and people, they come from top talent universities, CPFL, ESA, the Imperial, Polytechnica in Valencia. Well, as you can see, more than half of our employees, they have degrees in AI data science. So primarily we have engineers in the company, and we have more than 20 publications now in leading AI and machine learning journals. And basically we say it's world-class talent because also they continue bringing these things now into our company, our culture. We have continuous learning and upskilling. To give you some numbers, more or less, every VCME spends 60 hours in training, either internal within the projects, I don't know, certifications or more formal parts. And then we have 77% of our engineers now that are certified in different 7, let's say, AI architectures and solutions. And well, as we love learning, we also will keep pushing for this spirit of collaboration and also innovation. Like, for example, the project we did with Firmenich, I think it was in 2018, so already more than 3 years ago, we did Gen AI, no? And now it's a big topic. We can say that we did a little bit ahead of time. And yeah, basically we have different expertise in different industries. We work with the healthcare sector and also with what we call consumer packaged goods, that is manufacturing, energy, finance, and other sectors. And basically, I think last slide on my side to give you a little bit more visibility of what we do. So we try to, let's say, accompany the client the whole data journey. So we have a team that is more in charge of the strategy and understanding what they need. And then we have now our engineering team that they do the cloud engineering part, data engineering, data science, and machine learning. So with that, if you have any other question or afterwards during the apéro, you want to discuss more about Visium opportunities, our team will be there. So I won't, let's say, take more of it, I don't take time. And yeah, well, some of our clients, so you get an idea. Victor.
Yeah, okay, so what is RAG? Actually, that might be an interesting question for this workshop. So let's spend a bit of time explaining the different parts. So as I said, RAG means Retrieval-Augmented Generation, which means that you will generate some answers with a language model based on retrieved information. So you can see that here you have a database in the documents, and then you will ingest data. So this represents your original data, basically that can be PDFs, text, CSV, any kind of data. You will chunk it, which means that, for example, for a PDF, you will take small parts of it, like 1 page or sentences only. So this will be considered chunks of the documents. At that point, you use what's called an embedding model, which is a model that receiving text. And here we focus on text only, but you could also do that with images or different sort of data. You will transform that information into vectors and embedded document that you store in a vector store. So that part we use Chroma here. So we will get in more details about every part. This is just an overall view of the system that RAG is. This vector store, basically, it helps when you ask a question, that how you can retrieve information that's coherent, that is close to the question you asked. So basically, the embedding, obviously, feel free at any point to just ask if I'm going too fast or not giving enough details. Just if you have questions, just raise your hand. This vector store is used for search, basically, because if you have different PDFs, it can be quite difficult to find the one that has the information that you're looking for. So by transforming the sentences into vectors, into numbers that represent meaning, so that's the role of the embedding model. It's transforming sentences into vectors that represent the meaning of the sentence. You can find two very close vectors, two very close value, which mean that the two sentences have a lot of similarity. So this is used for retrieving information. Is it clear, this part of the RAG? Have you maybe heard of the, when you do embedding of words with Glove maybe, or Word2Vec, you have this kind of representation, right? Some vectors, and you have this analogy where you can say that the vector between king and man is similar to between queen and woman. So this is kind of the same concept. You transform sentences into values that represent the meaning, so that you can retrieve relevant information when you want to look for it. So once you have those chunks in the vector store and you want to retrieve them, once you retrieve the most relevant chunks of data, that becomes the context. So you retrieve the sentences that are the most relevant to your question, and you put that in the context. So here, this is back to text. So you use, yes?
Just to clarify the directions in which the arrows are going. So basically you have your query, and then which is basically the question you asked your model, let's say, and then from there you get the information from the documents which you chunk, and then you get to the embedded model. Do we agree on that?
Yes. So I was going through the blue, basically arrows, but yeah, it's kind of a more complex system. But basically, when you ask a question, so here the query is also text, and the chunkings, you have text chunks. Yes.
But if I understood correctly, the documents are chunked and embedded only once and stored permanently in the vector store.
Right. Yes. So instead of having this classic database with, for example, PDFs, you chunk the documents and you store them in the vector store, where the index will be their vector representation, the embedding it's called, and that can be used to retrieve relevant information. And so coming back to your question, what happens is that the text chunks and the query are both text. In this case, we limit ourselves to text here. We don't go into images or anything else. So both these sentences or these text elements can be transformed into vectors with the embedding model in the same way. And from there, you can do a proximity comparison. You can say, oh, this query, once transformed into a vector that symbolizes meaning, it's very close to this text chunk. So those are the text chunks that you retrieve and you put into the context. And the query and the context, you then both give them to your language model, as you can see here. So LlamaIndex arbitrates that, so retrieving, concatenating, and then giving everything to the language model. And so the language model here receives relevant information retrieved from the vector store and can answer the question based on this information. So that's an overview of what RAG is, and we'll go a bit more in depth afterwards. Yes, I think you were first.
LlamaIndex concatenate. This is, can't we just concatenate?
You could do it by hand, right? But you could also do everything by hand. You could create your own LLM and you could define a vector store. So LlamaIndex, basically, it's really here to orchestrate everything, and it helps a lot. And it has like a lot of methods that will give you very easy options. For example, like you can concatenate in different ways. You can store in different ways. So this is really like an overall library to connect a vector store, like the vector database, basically, which is just storing information, with the language model, which is just answering questions. And LlamaIndex, in this case, it takes care of everything else, all the steps that you have to do, the chunking, and then storing in a certain way, retrieving the correct metadata, concatenating. So yes, you could, but basically that's doing it for you. I think here.
I just have a question. Does it use somewhere transformers?
I mean, kind of, yes. In general, the embedding model and LLM are large language models. So most of the time it's transformers, yeah. I maybe you could do it with other kind of models, but transformers is really the go-to nowadays with the biggest models. Yeah.
Also an option to summarize the context before putting into the LLM, because if you put directly the context, I guess it's going to eat up the context too.
Yeah, so there are a lot of different methods with the RAG. So you can just use a sentence and store it as is, and then retrieve it as is. And then you can basically store the sentence, but with the other sentences that surround it. Or there is a recent method, I think by Anthropic, if I'm not mistaken, where they do not embed the sentence directly, but they embed a summary of what the sentence represents in a larger context. And you can do kind of anything you want, basically, because there are a lot of different methods, and some are more suited to certain cases. Yeah, it's quite free. So here it's basically raw context and concatenation, but this is really an abstraction, and you could have a lot of a lot more things going on underneath.
Do you know if LlamaIndex has a real documentation? All I could find was guides and examples, but not.
I'm not sure about that. Yeah, no, I don't know. I'm not working with them, so I cannot say.
But there are people from LlamaIndex here.
Okay, so yeah, let's move forward. So first step. So here, so we're not gonna respect exactly that because, yeah, I mean, we might not have time. Luckily, the notebook is already filled, so you won't have to. Yes. The what?
What you get before you get to the LLM in the end?
Yeah.
Is it working only with Llama, or could you typically use it with any other?
No, you could. It's here. Those are the technologies we decided to use for this workshop. But basically, you can use any kind of vector database, any kind of orchestrator, and any kind of language model. So this, like in these 3 steps, it's only that we decided to use that. Also because we wanted to do everything locally. So Ollama, for example, is to have local models, and so here, this is just a choice, but you could go with anything else. So yeah, so for the workshop, so right, first we're gonna set up Ollama, especially because we have to download the models, so we're gonna do that now. And then get started through so we have a notebook basically where the different steps are implemented, and hopefully we have a bit of time in the end to go further or discuss or play around with the model. So here you can find the repo where you should hopefully find everything you need. Sorry. Yeah, please go ahead. Rewrite it if you want. Is it okay for everyone if I move along? Yeah. Okay. So in the repo you should find some documentation, and then a notebook where you in one of the folder you should have a notebook, which I think is called workshop.ipynb for. So this is a Jupyter notebook, and you have all the exercise in that notebook. So basically, first step is just downloading Ollama. If you haven't, yeah, if you have it already, it's great. Otherwise, let's quickly go through the installation. So for most models, it's quite big. It can be a few gigabytes. So the idea here is that once the model is downloading, we can maybe already move along with the next steps so that we don't lose too much time waiting on it. And also, there are different models on Ollama, so maybe if the bandwidth is not good, maybe do not download the biggest ones. There are some smaller Llama 3 models, for example, like the 1 billion or 2 billion ones. Here you can also list the models you have. So as you can see, even if you get the app, it might take still a bit of time to download the local model, but hopefully you can do that at some later points. Sorry?
It's 600 megabytes.
Yeah, it's smaller. I was suggesting some, at first maybe this one, the 1 billion one, but tiny might be better. But if the app is not going through, I think it's kind of useless anyways. So you can basically just run a model from your terminal. Which one? Let's go with 3. And so everything here is going, it's happening basically on the device. You don't have to be connected to the internet. You have the model downloaded locally and running on your personal computer. So we can just ask a question. Anyone?
What is ETF after this?
And this is Llama 3 answering on the local device. So obviously it takes a bit of time because it's still a big model, but I hope you're reading everything.
There's a quiz at the end, by the way.
Exactly on this question. No, obviously not. Yeah, so this basically you can chat with the model on your local device. So everything is local. And this, once you've installed it, you can install different kind of models and you can use them also in other apps. So that's what we're going to do in Python. So here, this is Ollama used in Python. So you've got the library here, and you can basically generate some questions. Oh, exactly the same one. So yeah, so here you have Llama 3 answering to the question locally again, but from Python instead of in the terminal. So that way you can connect it to other libraries and your apps if you're coding in Python. So yeah, that was for the first part. I hope it goes through. We still have an hour or so, so maybe it will finally complete. So here for PDF, yeah.
Does it automatically run on M1?
Yeah, I think so. This is an M1. I don't think I had to do anything special to make it work. So I guess. Right. Yes, I think they do have support for that. So.
From a console that does not have a GPU on its computer, will it take forever?
No, actually, like I think Ollama, you can also run it on CPU. For small models, this is something that runs quite quickly also on CPU if the model is not too big. So yeah, so that's the yeah. Sorry. Yeah. Thank you. Yeah, so here that was a suggestion for PDF that you can store here, basically. That some of you might know, the Gospel of the Flying Spaghetti Monster, which is quite a good read, if you're interested. Okay, so now let's go to the setup of the vector database and storage backend. So here, basically, we use Chroma DB, which is this vector database. So this is, again, a library in Python that can be used to create this locally. So in this notebook, basically, we create the database. The client is ephemeral, which means that it's going to be stored in RAM, basically. In memory, it's not going to be stored on your computer. So it's not preserved at the end of the session. But you could also create it with persistent client and a path, and that will save your vector database permanently so that you can connect back to it and create later if you stop or restart the app. They also allow to connect to remote, for example, cloud vector databases. So here we create this client and a collection in it. So a collection will be used to store your chunks and your vector database. Sorry, your index and everything that's related to what the documents you want to create. So now we go to LlamaIndex and we connect LlamaIndex. We connect LlamaIndex and this vector database. As you can see, they have some, for Chroma, for example, they have this Chroma vector store, which allows to connect to the Chroma collection we just created. So hopefully it works. I don't know why I have this warning, but yeah. So here we create a vector store. That's an instance that's used to store vectorized chunks and index in LlamaIndex. And then this points towards the Chroma collection and the Chroma database we created with Chroma before. And the storage context, it's basically taking care of how things will be stored retrieved in this particular instance. And here, as you can see, it's from default. So basically, it can retrieve that this is Chroma and behave accordingly. How's it going with the download? No. Oh, 97 for the Ollama only, or? Okay, cool. So we still have time. Maybe you'll get some tiny llama. Sorry? Ah, okay. Yeah, too many llamas on the line, I guess. Oh, sorry. Yeah, so this is the creation of the vector database. Let me just go back to the slides. Okay, so this is a small presentation of Ollama. So that's for local language models, basically. So here it's for RAG, but basically you could use it for any kind of application that would require a language model. And this can be run on local device. So that can be your own device, or that can be servers, for example, in a company that want to run things locally. This is very useful if you want to do just apps on your computer, for example. But those are quantized models that basically you can use very easily and that are quite lightweight for how powerful they are. You also have embedding models on it, but that's not what we're using today. In the notebook, basically, we also need to download some embedding models from Hugging Face. I'm not sure this will go through, but we'll see. So here, so LlamaIndex and ChromaDB. So as presented, we just created the vector database, and then we have LlamaIndex that we'll be using to index the documents and save them in this vector database. So here is a small presentation of what that is. Sorry. So the vector storage, I already discussed it a bit before. I don't know if you want me to go through it again on what exactly is stored and how exactly it's stored, or if that was enough. If you have any questions, yeah.
How long is the term? It's like a sentence.
It depends. I think you can really, so basically you can store a lot of things, and the really plus of these databases is that you can retrieve based on proximity of the vectors, but you do not have to associate a sentence. Okay, I'm going a bit into details. I don't want to confuse anybody, but you are not forced to associate, for example, the vector of a sample to the embedding of its associated sentence. You can store a bit everything you want, but it's very useful when you want to retrieve things based on embedding proximity. So that's what it's used for most of the time. But it does not have to be a sentence, or it does not have to be a single sentence. It can be images, it can be a lot of different things. But the point is really this proximity of vectors. That's how you can retrieve it efficiently. And so here you have a small presentation of how you can retrieve the documents. Most of the time it's approximate nearest neighbor search. So you don't do a nearest neighbor search through all the documents, otherwise you'd have it would take a lot of time. You kind of find more or less the closest neighbors. I don't know if I have time to go into details about the algorithm, but we can come back to it later if you want. So this will find the closest vectors, sort of, but it's usually quite good. Right, and LlamaIndex. So this is, as discussed also earlier, this can help connect databases with language models and operate everything. So it can help you split and encode the data the way you want in the database. It can help retrieve it. It can make the embeddings and vectors different. It can retrieve the data and concatenate with the context around it, summarize, give a summarize to the model, give a prompt to the model. So this is really what you will use to put everything together and build your system. And here we use it for RAG. This is something there, it's quite suited to. And you have a lot of different options to improve or modify or custom your RAG. And so this is ChromaDB. I think we went over it quite a lot already. So this is what we use as the vector database. So that will be for storage and retrieval of the information. And this is kind of the whole process. Again, I don't know if you want to go through that, but here, yeah, you have objects and embedding model. So that's what we do through this workshop. You get a vector and you use that to find the closest sentence basically to your question. Again, so this is kind of how you measure distances, but let's keep that for now. So if we go back to the notebook, so here we created the vector store and storage context. So this is the connector between the vector database and LlamaIndex. And here we can start loading documents. So in LlamaIndex, they have this simple directory reader that you give a directory to, and it can fetch all the data in it. So here, that was a PDF document that we downloaded earlier. Here in documents, we can quickly display it. We retrieve this kind of information. So maybe I can zoom in a bit again. To light mode, yeah, sure. I'm not sure what this is, but do you get where?
You have your.
If you see it, isn't it in the settings though?
You can just command -B or command shift B.
Yeah. In theme.
Preferences, color, theme, field option.
Sorry, which one?
Yeah.
Here.
And then light.
I'm not seeing a light plus, light modern, light. Do you have a preference? Maybe this one is enough.
Doesn't matter.
Okay. Yeah, that's much better, I agree. Right, so this is the content of the documents we retrieve. So this is from a single PDF, but I think here it's actually split by page. So each of this line will be one page. And as you can see, you have an ID for it, some metadata, and the text it contains. So for example, the first page, I think it's just an image, so no text. Second one must be the author. And then you have more text for the following ones. So here, three important features we can discuss quickly is the metadata, where you have a lot of information about the document, file name, page, path in your computer, for example, here. The text is basically the text that's extracted, and text template that you can see here defines, in this case, how the models will see those documents. Yes, please. I think I just said, so here, no, you have to download it first. Yeah, if the Wi-Fi permits it, allows it. Yeah, and so here text template, it defines how the document will be displayed. So here you can see that the template is the metadata and the content following. So you will get some metadata put in front of the text content while the model see the documents. That means that it does not only see the text, it can see the document name, it can see the page from which the text is extracted. So for example, if you ask the model to cite the document, it knows what document the text comes from, and it can cite it for you. Okay, maybe let's pause here. Is it clear? Should I go a bit slower? Is it enough, not enough details? Too many? Yeah, and the pace is also okay, because we lost a bit of time, so I'm rushing a bit through things, but I can slow down. Yeah, we do? Okay, sounds good. So yeah, so this is what's extracted from one PDF that was saved in this path by the simple directory reader from LlamaIndex. And as you can see, it's quite, extensive. Right, so at this point, we have these documents in memory, but we want to store them, to index them so that it gets into the vector database and it can be retrieved and used by your rack system. So here, beautiful downloading of another model for embedding this time. Wait, no, I should have it in cache. Yeah, okay. Got scared. Quick note about embedding and the model. So usually the embedding models are not the same ones that you discuss with. So you have models, language models like the one we want on Ollama that will converse with you. They can answer questions. You can ask a question back. Embedding models are most of the time models specialized for creating vectors that represent the meaning of the sentence or text they receive. So you give it, so that's how we discussed earlier that the system worked. You give it a sentence or a chunk of text or even single words or full pages, and its role is to give back a vector that represents well the meaning of what you gave it, the text you gave it. So this is not the same model here as the language model that will answer your question. So yeah, here we load this model. And here with, how's it going with, yeah, please.
How do I know which embedding model is the best for my application? How can I evaluate this different embedding models?
Yeah, that's a good question. So here, for example, we take this model, which is usually quite good for rack systems, but that's part of the things you might want to tune. So I guess maybe some models will be more optimized for particular kind of data, maybe some for images also you would need, because if you start mixing different kind of data, it might not work well. I think you've got some insights on that, or yeah.
They have some leaderboards. You can check the sentence transformer models. There are leaderboards where they rank the model by different tasks, question answering, information retrieval, re-ranking, and so on. And even though it's called sentence transformers, they are actually suited for document embedding. So just check the leaderboards on the interface.
I use now a sentence transformer, and I was just not sure which one the best.
Yeah. Well,
I think depending on your task, you can indeed get some insights from this leaderboard, or then you just have to experiment by yourself and run some checks behind to maybe find the one that works best for you.
Thank you so much.
Yeah, thank you. Thanks a lot. Right, so here we loaded the embedding model. Is it still downloading for most of you? I just hope that by the end we manage maybe to do a tiny bit, but that's doubtful. I'm sorry. Right, so here using LlamaIndex, we create an index. So the index will be used to store data in the vector database and to retrieve it. Here we create it directly from the documents. So we give it the documents that you could see here earlier. And the storage context. So this is the connector with the ChromaDB, Chroma database that we also created earlier. And we give it the embedding model that will be used when storing and when querying the database. So this, if we go back to the original map of what a rack system is, this model that we just downloaded will transform the text you have into vectors, and that will retrieve the correct information or the most relevant one in your use case. Show progress is just to see that it is indeed putting the, oh, sorry. Right, so just here, it parses nodes. And here, this generating embeddings is the text going through the embedding model and being transformed in vectors for the retrieval. So here we should have all the text I showed earlier in the vector database that we created. Once again, we created it as ephemeral. So this is not saved on your computer. This is in memory. Yes.
We compute embeddings for the whole page.
Or does it like?
So it depends. But that's a good question. The embedding models, usually they create an embedding, a vector of the same size for any length of text. So if you give a short or a long sentence, you will have the same dimensionality for the vector. But it depends on how big or how small you want the sentence to be. I think in RAG system, usually they find that using smaller sentences work better because you lose less fine-grained information that you might be interested in. If you have a word, for example, that you look for that's really lost in a big page, it will probably not be well represented by a vector that embeds the whole page. So you might want to play around with that, also the length of the sentences. If it's a full page, if it's a smaller, if you have you add some context around it. So all of that can be switched.
We're somehow just using default setting.
Yeah, so indeed here the documents I embed are from the simple directory reader, which I think by default takes the text from a whole page. So this is here 1 page per document. But this can be tuned, and this probably should be, I don't think the default is the best way. Yeah.
Can you go up just a second?
Mm-hmm.
So yeah, stop here, please. So input text node, does that mean that it sees the text in your, because we said that text in the database would be like vectors, and each document, of each page or something would have like a vector associated.
I'm sorry, I'm not sure which part you're referencing.
Just here, from LlamaIndex.code.schema input text node.
Oh yeah, okay, so this is the type. So this is the class type. So here, basically, all of these lines, here I'm printing them in a data frame from pandas, but basically all of these nodes here are a class text node. So, and a text node, it contains all of this. So this is all what you will find in a text node. And so you have an ID to identify it. You have some metadata for it. Those I didn't go over, but basically it's the metadata you don't want to show the models while creating the context. This you can use to tune the relationships between the nodes. This is the text. This is some other kind of information. So one line is one text node class, basically. And it could be something else. You have a lot of different options. So here we work with text nodes because we get data from text, basically. That's why you have the text also here, text column. Yeah. We'll go. Yeah. So here the chunking, if you want, we could say that it's done by the simple directory reader, yes, because we get the whole PDF, and here we split the different pages and we extract the content from each page, and one node will basically have the text from one page. So this is already some kind of chunking, yes, but you have a lot of different kinds you can use. Basically, you can also chunk by sentences or paragraphs or any other sort you can come up with. This is the simplest chunking strategy, where it's just one page, one chunk. So yes, please.
What about this table? The column relations. So you compare data as graphs, and you know the relations between the nodes.
Yeah, I think you can. So that I'm not really familiar with, but I think you can indeed like define some relations between the different nodes, and probably you can do some operation that connects that makes use of the graph representation. Yeah.
That was actually my question.
Okay, but I don't know. Maybe some people more could help with that, but I'm not super familiar with this particular case. Yeah. Should I continue? Yeah. So, right. So here we've embedded our data in the vector database. So we can now retrieve it. So here we still don't make use of the language model from Ollama. Here we only retrieve using the embedder. So obviously this is related to the document we embedded. And here you can define, so basically you get a retriever from the index. So remember the index has all the information and methods to store and query data from the database that you put behind, which here is ChromaDB. Here we say similarity top K3. This means we'll retrieve the three most similar nodes. So the three vectors with the data from the three nodes that have the closest vector representation to the query. So here we use the retriever to query some documents. And that's what we get. So we get these three nodes. As you can see in the metadata, you have like the page, for example. And here you have the text. So basically this is the retriever. Congrats, you've retrieved some documents. And this will basically be used when you do some RAG system. This is the part. So we can maybe go back to the slides. Let me just so that we summarize what we've seen and connect it back to the graph, the original image. So here we had the PDF that got ingested and chunked by LlamaIndex. So here the chunks were pages. And then this was given to the embedding model and stored in the vector store, right? Then what we just did with the retriever was to give a query. So we give the query to the embedding model. It gets also transformed into a vector. And this embedded query retrieves the three most similar nodes. So that represents the three chunks that, in theory, should have the most relevant information for the question you just asked. And this was returned, not yet in the form of context. Here, we just got back the nodes, the raw nodes, and we'll go now to the last step, the last part of the RAG system, which is how to get this context, a prompt, the query, put everything together, and get an answer from the LLM. Is it good? Do we continue with that? Any questions at that point? Any Ollama download that went through in the end? Yeah? Okay, 1. Oh, 2, 3. Okay. Okay, but yeah, good to hear. Maybe you can play around by the end. We'll see. Okay, so this was retrieved. So here we get the three most similar nodes with the most similar data. Again, this is in theory, because here, for example, I have one single small question, but this is compared to full pages of text. So this means this full page is, according to the embedding, the most similar to your question, the most relevant. This should be tuned probably, and you can do it with LlamaIndex. I don't know if we'll have time to really go in depth with that, but this is what's happening, and this is an element you should probably tune. Is it, by the way, am I going too much back and forth? Is it really bothering you for the sound, or is it fine? Yeah, it's not making waves. Okay. All right, so let's put everything together. So we played with Ollama. We created the vector database. We connected it to LlamaIndex. We created a retriever with the embedder. We retrieved everything. Great, we have all the elements to finish the RAG system. So here, using LlamaIndex, we get a connector to the Ollama model. So Llama 3, in this case, the same one we used in the command line before to ask a question. But what we'll do here is not simply ask question to the model like you could, is create a query engine. So from the index that we created. So this index that helped us put and retrieve data from the vector database, it also allows to create a query engine by being provided with an LLM and again, some parameters. So here, this is just the number of nodes you want to retrieve. And this is just a parameter that says that the answer will be streamed. So as you can see, if we ask the same question again, we can get an answer based on the 3 nodes that we retrieved earlier. And this is all going on locally on this device, which is not too hot. And here you've got an answer that's related to the document you gave it and the question. So again, there will be a test. Please memorize it. So this is your first rack system, very basic. And here you are, and you can give it any kind of documents you want, any kind of model, more or less powerful, and you already have something working. So that's it, everything local, and you can play around with it. Right, so at that point, I was like expecting that everybody would be going a bit through it on their side, so maybe we are a bit early in the end. But there are just a few other options. I didn't put too much here. A few other options basically that you could, in theory, use. Any questions at that point? Yeah.
Can you access? So you said there are 3 parts to the query that you give to the LLM.
Yeah.
Can you access that? Because here we've just got the one, the query.
You mean, can we access, for example, this element? Yes, you can, and you can modify it. And this also here, like basically how what's given to the embedder is also something you can access and you can modify. And we'll not go too deep into it, but I'll quickly show how you can do that and some options to modify it. I don't know if there are other options to modify it though. I don't remember if I left it or not, but we'll have a look. Yeah.
Why would you want to modify them actually?
Because so here, I'll show you. I'll show you how the default works, and then we can discuss if we want to do these things differently. So here, the first, I guess, one of the big changes you might want to make is changing the prompt. So the prompt is here. It's basically what you write around the query and the context. So here it says system prompt. Like it depends on the model. Some models, they receive really different input for the system and for the question. So it might actually, well, okay, this graph does not represent exactly what I'm going to show you, but this is a simplification, I guess. But this would be the template for the question we will ask the model. So in LlamaIndex, you have some default templates for the, I guess, retriever. I don't know if there is a template for the retriever, but at least for the query, for the chat model also. So I did not put that in the notebook, but you also have the option to have a chat, which means that it will not just give one answer, but you can keep going with the same discussion. And there is an option to have this chat with memory in LlamaIndex. Here, it's not a chat, it's a retriever. So if you do not provide it with previous context, it will not have access to it. But the chat does that by default without you having to create the extended context. So here, let's change the template for the query. So as you can see, here you just give it some instructions. So for example, still based on spaghetti, flying spaghetti monster, we give it some clear instruction about its desires, beliefs, and behavior. And this, we put it as a prompt template. And this will be a question answer template that we provide to the query engine. So here we recreate again a query engine, but we give it also the text template, this text question answer template. So this here will modify what's received basically here. So this modifies it to some extent. As you can see, this does not define, for example, how the context string is done or the query. This create a prompt around it. So let's try it and let's see if something changes. Remember, just like, okay, this was the original answer. Okay, that's a bit different. Yeah, so first easy change, just change your prompt. And based on your task, you might want to say that the model is like a specialist in healthcare or security, or ask it to be very defensive or very nice to you when you ask questions. Just you can change style, you can change expected behavior, you can change format also. You can ask it to be very short or very extensive, go into details or less. Yeah, so first easy change, just play around with the prompt. Yeah.
About slides you have on the diagram with the system prompt.
Sorry, here? Yeah.
Does modifying the system prompt is, I mean, what you understand,
Mm-hmm.
does modifying the system prompt lead to higher changes compared to, because the same instruction that you put in the system prompt.
Mm-hmm. So I think that is very dependent on the model you use. I'm not sure for Llama 3, but I guess some models are trained with the system prompt, some are not. So I think this probably depends a lot on the model you're using and how it's usually prompted. Again, that's why I said before that I don't know if this qualifies as system prompt per se. This might be more about, I don't know, concatenation, like changing the concatenation. But again, this is not ground truth. This is just an abstraction and simplification of the system. Yeah. No? Please go ahead. Sorry, number 15. I don't know if... which one is it? It's down.
The one with the query index.
The first one or this with the... Okay, this one. Yep.
Understanding I have is correct. Index is the vector database. And then
So
the index is the vector database. That was why I'm passing the LLM database and not the other way around. Since
yeah.
the vector database, which queries the LLM, not the other way.
Yeah, so the index, I don't know if you can say it's really the vector database. Here, the index, I believe, is more like an abstraction from LlamaIndex that will behave as an index, but still offer the opportunity to generate query engines, for example. So, I mean, the index, you could say that the term is widely used or sometimes used for only the vector database where you have the index and the indexer and everything is related to the storage only. Here, I think it's more an abstraction that takes care of that and that can be queried to, you know, generate a query engine, for example. If we go a bit higher, yeah, vector store index. So I think this is, yeah, it's just like a term. I don't think this.
What is that?
It's a vector store index. I mean, that's the class name. I mean, maybe you can, I don't know, raise issues about the documentation or these kind of things.
Here, tell us.
But yeah, so this is like an object that takes care of everything related to the database, but also offers the option to generate, like to have engines, basically. Yeah. Does it answer your question? Okay. Yeah, I think we had a question here also, or?
No, I just want like vector store index is just a buffer. That's a class.
Mhm.
That allow you to read something like a lot of vector database. So when you do as code engine, basically you instantiate a synthetizer, so something that will take things from the vector index and inject it inside the prompt. So it's
Mhm. So it takes care of both parts, basically, I guess. So, thank you. Any other questions, or? Yeah.
If we take the system prompt, could we make it so that the LLM only answers if it finds relevant information, and if there's no information in the documents, it just doesn't answer?
I guess probably, yeah. I think you could specify that. You can say, like, if you don't find anything that's relevant to the question, say it. Or you could also ask it to say, if nothing is relevant, pretend something is. I don't know. I think it's really dependent on the model. Depends on your goals.
Always find 3 or however much specified documents.
So here, this so yeah, the number 3 here is a parameter you give. I guess yes, like it will retrieve the 3 top closest documents, even if they are not that relevant. Again, it will depend on a lot of parameters you have to tweak to have something that's working well. But yeah, definitely you can precise in your prompt that you want the model to be very honest about not having relevant information. You can specify that it should or shouldn't use its own knowledge to answer. Also, you can say only work with the documents. Yeah. So that's quite free. But given the knowledge we have about how much prompting can change the model's behavior, this is something that I would say is quite important when you try to improve your model, or at least the answers. Because here, this is not related to retrieving. So that will not, changing this prompt will not help retrieving, but can help extracting better information from the retrieved chunks, basically.
Try to wrap up by 45.
Yes, sure. So that was the prompt. Here you see that it basically changes the type of answer. And then you can obviously go through better embeddings. So here I just had a few examples. So here, this is okay, so that was just the nodes that were returned by the previous square. And then you see that here, this is the text that's given to the, like, this is the text that's stored in the node, in this node in particular. But I don't remember whose question that was, but this is actually what the embedder will see when embedding the model, the chunk. So as you can see, here it sees some metadata, including page label and file path. So here, for example, I'm not sure this is something you want to embed. I don't think this is very relevant to have the full path, but that might be useful, for example, if you want to have an app where you can click on some retrieved information and be directed directly to the file. But the file path, for example, I would argue it's not very relevant for the query model. So this might have to be modified. And here you also have another option. That's what the language model see when you retrieve the document. So again, in those two cases, they are identical, but that can be tweaked. You can give, for example, for the embedder engine, just one sentence, but give back a bunch of sentences to the language model. So this is a possibility. You can change the metadata you want to provide. You have a lot of options regarding that. And here, so for example, you can, so here, for example, you can define a sentence splitter with the chunk size of 200. So as you can see now, we are embedding a lot more nodes in the database because we specify that we want to split at the sentence level with a limited size for the chunk. So instead of embedding full pages, it will embed these smaller chunks. So that's already a tweak you can make. But for more complex transformation, and especially I think the time is right, I would encourage you to go through LlamaIndex, which I understood some people are not fond of regarding the documentation, but they do offer some other methods that you can use to make more complex processing before embedding and after retrieval also. Let's quickly go back to the slides. So this is embedding. Yeah, and so basically we also had like a Streamlit app where you could fill in some code to have something working and try and customize it a bit. I guess that's it. And yeah, happy to answer any questions regarding the workshop. Maybe Maria can help with the questions regarding the company. Yeah, and just if you want to chat also, please feel free to come. Thank you.
Yeah, we have a couple of Visium people here who are happy to chat with you. There's actually there's two over here. If you can raise your hands. Yes, you. I don't remember. Visium people, and then there's actually two LlamaIndex people here as well, right next to them. If you want to chat with them, and then yeah, Maria in the back and Victor, right?
Yep,
Victor as well here. So we're gonna switch, or if you have any questions, maybe you can handle them with them directly. And we're gonna start with the pizza apero, which is just over next door. Things to keep in mind: start with one slice. Don't worry, there's plenty enough for everyone. You take your slice, you step away from the table, okay? Make space for other people. But yeah, let's give another round of applause. Thanks.
Thank you. Yeah, so happy to answer any questions. Also, sorry for the bandwidth, but you have access to the code. You can play around with it at home or. Thank you.